Okay, here we go. Question number 1 says 2 moles of HI are placed in a 1 liter container at a certain temperature, and the HI dissociates or decomposes according to the following equation. It is a decomposition reaction that is endothermic. Agree with that statement? It is endothermic. Right here, the heat says to me, I am endothermic. That's going to be important for other questions down the road. All right. So, I forgot to add the other piece in, didn't I? The other piece on here says, if when equilibrium is established, it is discovered that 1.60 moles of HI exists, calculate the value of Kc. So we're kind of missing that one piece. Forgot to cut and paste the bottom part. So we are ready to show our equation. So let's rewrite it. 2HI. We'll just go ahead and write in the word heat. Yields an equilibrium, H2 plus I2. Now, all I need is this beginning part to write down 2 moles with 1 liter, 0, 0. Why am I putting zeros at H2 and I2? Because they're not mentioned, that means they're 0. All right, then in my ice chart, I'm going to write down minus 2x. Why am I putting 2 in front of my x? Because I have a coefficient of 2 sitting there. And then I'm going to come over here and put plus 1x and plus 1x. So I have x, x. I have 2 minus 2x. And then they tell me in the rest of the problem that that value right there is equal to 1.60. Yes? So in other words, they gave me the value of x. Inadvertently, right. It's not x directly, but it allows me to get to the value of x. So if I will do my math and say 2.0 minus 1.60 equals 2x, I'll discover that 0.4 moles equals 2x, and thus x is equal to 0.2 moles. Agreed? Okay, so now I know that this is 0.2 moles. And this is 0.2 moles, so I know everybody's mole value at equilibrium. I know that I have 1.6 right here, I have 0.2 right here, and I have 0.2 right there. Agreed? Yep. So can I find the Kc value?
Yes, you can.
Yes, I can. Okay, so we're going to say, let's just go up a little bit. All right, Kc, the expression is going to be H2 times I2 over HI. What do you have to do to HI? Square it. So I'm going to plug in 2 moles over my 1 liter times 2 moles.
0.2.
You're right. I'm wrong. I always make mistakes. I make them all the time. 0.2 moles. 0.2 moles, and yes, Eric, I know we could just square it, but we're not going to do that right now, Eric, especially since you're not here. You don't have a voice since you're not here, so. Okay. Divided by 1.6 moles over 1 liter squared. Now, what's going to happen to my volume? Going to cancel out because I'm going to have 1 liter on the top squared and 1 liter on the bottom squared. So technically, no matter what the volume is, it's going to go away. Which means changing volume doesn't affect the equilibrium here. Since the volume cancels out, changing the volume does not affect the equilibrium because it'll cancel out anyway. Okay. Now, when I plug that all in, Brian, what did you get for the Kc value? 0.01, okay, 0.016. All right, Taylor, help me, help me, help me. What does that say to me? It speaks to me. What does that say to you? It's reactant favored. Jessica, what else does it say to you? When the Kc is 0.016. Cameron, not spontaneous. Sean, what else does it say to you? Not TPF. Elizabeth, what else does it say to you? Positive delta G. Yeah, what else does it say to you? Thank you. Negative E cell. Yes, because that's a small k. It's a small k, yes? Okay, so it speaks to me. Those k values need to start speaking to you so you can connect equilibrium with thermochemistry. They do go together. And electrochemistry. It all goes together. Because this is a redox reaction. Bet you didn't know that, but it is. It's a redox reaction. We can do oxidation numbers, find an E oxidation and E reduction, add them together, get an E cell.
No, Miss Matney, stop.
Get our delta G. Oh, we can even do rat link with our K and go backwards to get the delta G.
Are we going to have a unit that ties them all together?
Called the AP exam.
I'm not taking it.
Yes. All right. So that's question number 1, first part. Second part says, what's the value of your KP? Yow. Okay. The number of moles of gas on the reactant side is 2. The number of moles of gas on the product side is 2, looking at coefficients. Therefore, no change means Kp and Kc are the same values. Yes? It means volume cancels out. It means I can't predict the sign of delta S. It means changing the volume will not affect this equilibrium.
Yay.
Thus, changing the pressure will not affect this equilibrium.
Yay.
Changing volume, changing pressure means no change. If there's no change in the number of moles of gas, there's no change or no effect on the equilibrium when you change volume or change pressure, and that's kind of some new information. All right, so we're ready for question number 2. Question number 2 says this. Where is he? There he is. Kc is 5.6 times 10 to the minus 12 at 500 for the following. I2 plus heat yields 2I. All right, let's bring that down here. I2 plus heat, both of these are number 1 and number 2 are endothermic, yields an equilibrium 2I. All right. Kc is small. I'm just going to write that down here. Kc is very small. Says a lot to me. If a 2-liter container contains 0.02 moles of I2, 0.02 moles of I2, and 2 times 10 to the minus 8 moles of I is the reaction at equilibrium. Let's just stop right there. Just stop. These are initial values. Notice you have values of both. Do you know which way it shifts? There's no 0, so I don't know which way it shifts. So if I don't know which way it shifts and it asks me the question, is it at equilibrium? What is it? Q. It's a Q question. It's a Q question. Is it at equilibrium? Q. Is it at equilibrium? Q. Is it at equilibrium? Q. It's asking me that question. So I have to plug my numbers in to the expression which says I squared over I2. And let's find our Q value and compare him to my Kc. Thank you. 5.6 times 10 to the minus 8 minus 12. All right, so we plug him in. 2.0 times 10 to the minus 8 moles. My volume is 2 liters. Isn't it? Yes, it is. And the top one gets squared, divided by 0.02 moles, divided by 2 liters. Now let me show you, you do not need a calculator. 1 times 10 to the negative 8 molar squared. 0.010 molar to the first. Did I need a calculator to simplify that? No. 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 Okay. This is really 1 times 10 to the negative 16 divided by 1 times 10 to the negative 2. That's what it really is. Let's pull that up a little bit so you can kind of maybe see that. Extend my page a little bit. Thank you. That simplifies to that. Which means I don't need a calculator. It's 1, 2. Just 2. That's a 2. So this is 1 times 10 to the negative 14 answer. I didn't need a calculator for that. I didn't need a calculator for that.
But I have 2.
You got 2.
Well, 2 times 10. I don't know. I don't know.
Not if you divided this by 2. And not if you divided that by 2. Okay, so you get 1 times 10 to the negative 14. That is my Q. So how does KC compare to Q? Okay, because this is 5.6 times 10 to the minus 12, and this value is 1 times 10 to the minus 14. Are you sure that KC is less? Are you sure that KC is less?
No, it's not. KC's greatly bigger.
KC is bigger. So where's my arrow pointing? To the right. Okay, think about this. You got a negative 12 and a negative 14. Which one's bigger? Negative 12 is bigger than negative 14. Negative 12 is bigger than negative 14.
Never mind.
Okay, because I'm in the negative. And so it's got to be opposite from what I think. It's opposite from what I think. All right. So this reaction is actually going to shift to the right. It's going to shift towards the right until it reaches its equilibrium. Now, if I were to go back up here into my ice chart, I'd have to grab a handy-dandy eraser real quick. And we're not going to solve this because we'd have to do quadratic. So we're not solving it. But if I were to show what it did, minus x plus 2x, so that at equilibrium, I would end up having that many moles at equilibrium over 2 liters, and I would end up having this many moles at equilibrium. That would be my change, and this would be my E. Didn't want you to solve it, just wanted you to think about what is shifting towards the product side mean. It means you go do your X's, is what it means. Now again, why did I have to do Q here?
Because you do not know if it was at equilibrium.
I did not know if it was at equilibrium, and I had values of everybody. So I couldn't shift it towards the zeros because there were no zeros. Agree with that statement?